This is our first lecture of college algebra. Today we're going to learn about the books, our textbook that we're going to use, and the first lecture is about the number system, right? First, let's look at the book. The textbook that we're going to use for this course is from OpenStax, and it is a free textbook, and I added the links in there. You can also go online and search college algebra OpenStax, and it will take you to this page here, and you can click this download a PDF, right? If you do that, it will take you, the PDF will open. It will look like this, right? And this is free for all, you don't have to pay for it. All right, so today at first we'll look at the prerequisite for this course. The first thing we're going to learn is about the number system, the real numbers. Okay, it is a good idea to go through the books, like all these written before you move into the chapters, but read the books, right? It will give you a much better perspective on what's happening. Okay, so the first thing we're going to do is all the number system, right? So let's go to our lectures. Okay, so we are in a chapter 1. Sorry. Okay, all the number systems. Real numbers. Okay, so all the numbers we're going to use in this course are called real numbers. Okay, so the very first number system that the human came up with is the counting numbers. Another name is natural numbers. These are the numbers that we use to count, like 1 2 3 4 5 6. How many, the number of livestock that we have, number of units of certain grains that we have. These are used for trades and keep count of someone's possessions, right? So the first number systems are called natural numbers. This is called natural numbers because these number system these are the numbers that came to us naturally at the very beginning. And the way we denote this natural number is by n. Okay, so let me write it properly, okay, with this extra line, right? Now what are these numbers? These are the numbers starts from 1 2 3 4 5, go on and on. Okay, it goes to infinity. Then a bigger number set of this natural number is called whole numbers. The whole numbers are the same as natural numbers, but it just has 0 in it. Alright, so we start from 0 1 2 3 4 5 and so on. Okay, now this 0 came into much later on. The natural number existed like about 100 centuries before. The whole number, this 0, is included in the number system by Indian mathematician in about 5th century. A bigger number set than whole number is called integers. The integers are denoted with this letter Z. Okay. These are the numbers that included negative number as well. So the numbers would be 0, 1, 2, 3, and it's going on. And on the other side we have negative 1, negative 2, negative 3, and so on and on. Okay, it also has negative numbers. Now the negative numbers are introduced by same Indian mathematician about 7th century, and all the number system that currently we use, these are called like 1 2 3 4 5 6 7 8 9 10. These are the decimal system. These number system are called Indo-Arabic number system. It was basically discovered by Indians. Later on the Arabian took it, and later it spread throughout the world, right? You might see another type of number system, like we call it Roman numbers, right? We see that the Roman numbers are something like this: 1 2 3 4 is like 1V, 5 is V, 6 is 1 5 and 1. All right, we can still use this number system, Roman numbers, Roman numerals, to count the pages, right? But doing calculation is quite difficult using the Roman numerals, right? Using these decimal numbers or these Arabic numerals are very easy. Okay. Now, above these integers, the bigger set, the number set, is called rational numbers. All right. So, what is rational numbers? The rational numbers are denoted by a Q. Okay. What is rational numbers? Rational numbers are just the fractions. For example, let's say 1/2 or 1/3, because when there's some amount for counting that doesn't come as a whole, like let's say half a bag of rice, right? How do you say that? It's like we call it 1/2, right? That's half. 1/3, 1/3, or we can say something like 4/5. It means you divide something into 5 parts and you took 4 of them, right? All these numbers are called rational numbers. So what is rational number? Rational numbers are two numbers, two integers divided by ratio of two integers, right? Something like this: m/n, where m and n are integers. Okay, but we have one condition here: n is not 0. Okay, so the thing is, we cannot divide any number with 0. Okay, throughout the whole calculus, we're not going to do this. We will not divide any number with 0. Okay, we don't know what that is. We call it undefined. Okay, so these are the rational numbers. Now, the rational numbers are much older than these whole numbers and negative integers. Okay, so we also have negative rational numbers, something like this: 5/6. So all these are rational numbers. So rational numbers, the 1/2, 1/3, these numbers came in much before the negative numbers or whole numbers, 0. Like we have rational numbers about 4,000 years ago, right? The Egyptians used rational numbers in their calculation. Then we have another set of numbers, is called irrational numbers. Now these irrational numbers are denoted as QC. This C stands for the complement. Like all that are not rational numbers. Anything that is not rational are irrational. Okay, so what are some irrational number example? For example, the square root 2. This number square root 2, it basically means that when you square this number, you get 2. For example, if we had square root 4 is, or square root 9 is 3. It basically says if you square 3, if you square 3, you get 9. Alright, you get 9. That's what square root is. Alright, so the square root 2 is a irrational numbers. There is no way we can write this square root 2 as two numbers, like a ratio of two numbers. For example, we cannot write it like this, m over n. Okay, square root 2 is between 1 and 2, and it cannot be written as a ratio of two numbers. There are some other irrational numbers like square root 5, square root 11. We all know this pi, the ratio between the circumference and the diameter of a circle, that's pi. These are all irrational numbers. The math number e, these are all irrational numbers. All right, now together all these numbers together is called real numbers. All right, now the real numbers are denoted with this R, this double R. This is real numbers, right? These are real numbers are all rational and irrational number. Okay, now we have another bigger number set than real numbers. It's called complex numbers. We'll get to it later. All right, so how do you show a real numbers? So a graph of a real numbers look like a straight line. Okay, a straight line, it starts with 0. This is 1, 2, 3, and it goes on and on. And on the right side we have positive infinity. On the left side we have -1, -2, -3. We have negative infinity. All right, in between these numbers we have like rational numbers, like this is 1/2. Somewhere here is say 2.1. all right, these are rational numbers. And we also have irrational number between all of them, right? So between two real numbers there are infinitely many real numbers. We actually have a theorem for this. All right, all right, so now let's do a classification of real numbers. Let's do an examples. So there is similar example in the book. We can say the example 4, for example. The page number would be 10, page number 10, right? Let's say, for your reference you can go back and check. Now A, -10/3. B, square root 5. C, negative square root 49. D, -6 pi. And number E, let's pick a different number. 3.1441444, and it goes on and on with the same pattern. Okay, So the first one, number A. What do you think? What type of real number is this? First of all, it says negative 10 over 3. Both 10 and 3 are integers. So we know that it's a rational number, right? So the first one is rational. Number B, square root 5. So the square root 5, there is no exact number for this square root 5, and 5 is a prime number. We'll discuss what that is. Okay, so we call this irrational numbers. Number C, it says negative square root 49. Okay, now if you use a calculator, you will see that square root 49 is actually 7. Why? Because 7 square, or 7 times 7, is 49. That's why square root 49 is just 7. Okay, so this is just negative 7. So negative 7 is integers, so you just write this is integers. Number D, it says negative 6 pi. We know that pi is irrational, so if we multiply 6 with it, that's still irrational. So this is irrational. Okay. Now the most important, number E, it says 3.144. So we have a repeating pattern. Now if a decimal number has a fixed number of decimals like 2.5 or 2.76, 2.93, and it stops, then it is rational number. Or if we have a repeated number, then it's also rational number, so it would be rational numbers. Okay, and if we have a decimal that doesn't stop, it goes on, and there is no pattern to it, then we call it irrational numbers. Like pi, it doesn't have any pattern. Okay, now we pick a new topic. It says prime and composite numbers. So if a number is divisible by number, if a natural number is divisible by another natural number, okay, what do I mean by divisible? For example, we all know that 15 can be written as 3 times 5. 15 is equal to 3 times 5. Or 15 can be also written as 1 times 15, right? So these are all natural numbers. Okay, then what we say is 1 is a factor of 1 is a, okay, let's start with 3. 3 is a factor of 15. Okay, so is 5. 5 is a factor of 15. So is 1 is a factor of 15. So is 15 itself is a factor of 15. Okay, so this number here, these are called factors. These are factors, and these here are called product. Okay, so if we multiply two number and get another number, that number is called product, right? Okay, now in other way of saying this, 3 is a factor of 15. We can say 15 is divisible by 3. or 15 is divisible by 5. We can also say 15 is divisible by 3. Okay, we can also say 15 is divisible by 5. And so on and on. Okay, now what is prime number? If a natural number has no other factors except 1 and itself, then it is called a prime number. Okay, now my question to you guys is 15 a prime number? Okay, we can clearly see 1 is a factor. 1 is a factor of any number, right? And 15 itself is a factor of 15, right? So any number has 2 factors. 1 is the number itself, and another one is the number 1. Okay, so any number has these 2 factors. If it doesn't have any other factor, then we call it prime number. Okay, now my question to you guys, is 15 a prime number? Is 15 has only these 2 factors? No, the answer is no. 15 has 3 and 5. Okay, so 15 is not a prime number. It is called composite numbers. Can you give me an example of prime numbers? Yes, we can. Like 11. See, there is no number that can divide 11. Like pick any number, 1, 2, 3, 4, right? No, there is no number that divides 11, so we call it a prime number. So what other prime numbers do we have? The smallest prime number we have is 2, then 3. 4 is not a prime. 5. 7 is not a prime. 6 is not a prime. Then we have 7. 8 is not a prime. So any even number except 2 is not a prime. Okay, 9 is not a prime because it's divisible by 3. 10 is not a prime. 11 is. Okay, then the next prime is 13, then 17, then 19. 21 is not prime because it's divisible by 3. Then we have 23, and so on and on. Okay, the other number system is called composite number. If a number, okay, not just any number, if a natural number is not prime, we call it composite number. Right? Some examples: can be 4, it can be 12, all the others number that is not a prime. 21, Alright. Any composite number can be written as a some multiplication of prime. It's called prime factorization. Like 4 can be written as 2 times 2. 12 can be written as 2 times 2. Okay. Times 3. 21 can be written as 3 times 7. Alright. See, all these numbers here are prime. So you can multiply all these different primes and we can generate any numbers. It's called prime factorization theorem. Okay. Any questions so far? Okay. The next topic is some properties of real number. Okay. So these real numbers have some properties. So the first property is called commutative property. Okay, so we assume that any numbers a and b. Now we have two operations, so we pick two operations. One is addition, another is multiplication. But what is commutative property? For example, if we add two numbers like 4 and 6, is this same if we add 6 with 4? So basically what I'm asking is, if we change the order of our operation, like if we put 4 before 6 or if we put 6 before 4, does it change the value or not? Okay, we know that 4 plus 6 is 10, 6 plus 4 is also 10, right? So in both cases we have the same number, so we say the real numbers have this commutative property for addition, right? So if we add two numbers, then it's commutative. Okay, how about multiplication? Like if we multiply 3 times 2, is it same as 2 times 3? Yes, it is, right? In both cases we get 6. So the multiplication is also commutative. Alright, so my question to you guys, is subtraction a commutative or division commutative property? Have this commutative property? For example, if I ask you, is 4 minus 6 same as 6 minus 4? Is it? The answer is no. It's not. Okay, because 4 minus 6, you get what do you get? You get here, you get 2, and here you get negative 2. All right, so in both cases they are not same, so we say no, the subtraction is not commutative. Similarly, you can also check the same example with division. So subtraction and division are not commutative. So you say right, let's go to the next page. So what is commutative property? The commutative property, let's just write it bigger. Commutative property a plus b, a plus b equal to b plus c. Also, a times b is b times c. You say the addition and multiplication are commutative. Okay. Subtraction and division are not commutative. That's why in our algebra we often do not use subtraction and division. We can write subtraction as addition. For example, you can say something like this. Okay, give a subtraction like 6 minus 4. This is subtraction. You subtract 4 from 6. Now you can also rewrite this as addition. How? You can say 6 plus negative 4. Remember, negative 4 is just a number, it's just a negative number, but it's still a number, right? Here this minus sign is a subtraction. It's an operation. It operates between two numbers. This sign here is the same sign, same minus sign, but this sign is just a negative sign. Alright, so this is a number and we add to a number. So this is addition, this is commutative, this is subtraction, not commutative. So we can actually say this by subtraction. You can say negative 4 plus 6. It has these are the same thing. Okay, but 4 minus 6. Okay, so let's go back and delete this. So that's the commutative property for addition and multiplication. Then we have the associative property. A plus B plus C. Basically, associative property says it doesn't matter if you have 3 addition or 3 multiplication. It doesn't matter which one you do first. We all know that from PEMDAS, we always do the parenthesis first, right? So it basically says whether we add B and C first or A and B first, if this all addition is the same property. How? Let's do an example. Let's say 1 plus 2 plus 3 and another number. Let's pick 1 plus 2 plus 3. Okay, now if we do this, we get what do we get? We get 3 plus 3 or 6. Now on this side, if we add 2 and 3 first, we get 5. So in both cases, it doesn't matter which one we do first. In both cases, we get 6. Right? So this is called the associative property. Remember, the division and multiplication are not associative. Next one is the most important. We use this a lot. It's called distributive property. So this is where we incorporate both the addition and multiplication together. So we say if A times b plus c, then it is same as saying a times b plus a times c. So what is this distributive property is? It basically says you multiply a with each number of the parentheses. Okay, we can always check, like give some number whenever you have doubt on something. Give this ABC a number. For example, let's give this a number. Let's say a is 2 times b is 3 times c is 4. Okay, on this other side we do the AB times AC. A is 2, b is 3, a is 2, c is 4. Right, so let's do this first. 2 times 3 is 6, 2 times 4 is 8, together we get 14. Now what happens on this left side? So how do we do it? First we add the parentheses, we do the parentheses, right? So what's we have inside the parentheses? 3 plus 4. So we add this 3 plus 4 first. So it's 2 times 3 plus 4 is 7. What is 2 times 7? That's 14. So in both of these cases, see, we get 14. So remember, this is the distributive property. So another distributive property that we have, let's make it a little smaller. You know what? Let's make it a little smaller. Okay, so another distributive property that we use is something like this: a plus b times a plus c. This is equal to, okay, instead of a plus c, let's do c plus d, c plus d. So what we use here, first we multiply a with c and a with d, then we multiply b with c, b with d, and together we get ac plus ad plus bc plus bd. Okay, you might also know this and another name is called FOIL method, right? It has another name, something like this. FOIL. Let's use it darker. You might already FOIL, right? You might already know this as FOIL method. It basically says that so you do first, outer, inner, last, right? That's the number for FOIL. And two more properties is called the identity property. So for addition, there exists a unique number addition identity that when you add that number with itself, it doesn't change the answer, right? Oh, sorry. Additive identity is just 0. Alright, it says a plus 0 is a itself. Alright, so there is also a multiplicative identity. Multiplicative identity. Alright, okay, now answer me this. What is that number when you multiply with any number a, alright, and you get a? What is that number when you multiply with a? It doesn't change the value of a. Like let's say 5. Right? What is that number when you multiply with 5? It still stays 5. Yes, that is right. It's just 1. Right? So your multiplicative identity is just 1. Right? When you multiply 1 with any number, it doesn't change. Additive identity is 0. When you add a 0 with any number, it doesn't change the value. Right? The last property we have is called inverse. Okay. Now, the additive inverse so what are the inverse? Inverse are two numbers. When you add them together, you get the identity back. For example, let's say you have 5. What is that number when you add with 5? You get 0, because 0 is our additive identity. Similarly, the multiplicative identity would be is what is that number when you multiply with 5, you get the multiplicative identity 1. Alright, think for a second, pause the video. So here's the answer. What is that number when you add with 5, you get 0? That would be negative 5. Okay, and what is that number when you multiply with 5, you get 1? That would be the reciprocals 1 over 5. Okay, so we do this. We say any numbers, how do we do this? Okay, additive inverse is A is the additive inverse of any real number. A is negative a. Why? Because a plus negative a is 0. Similarly, the multiplicative identity, sorry, not identity, my bad, it should be inverse. So this 1 over a is also called the reciprocals of a, because when you multiply these two numbers, we get the identity back, a. Alright, so these are the very basic properties of real number, and we use just this, right? We use just few of these properties, like about 5, to do all the math that we're going to do this semester. All right, if you have any questions, please send me an email. All right, and we're going to do much more examples next class. Okay, bye bye, take care.